Economics video number 4. Today we'll be working on solving for present value. Solving for present value, 3 methods. So what we're going to be doing today is learning how to find P, find the present value, given a future value, interest rate, and n number of terms. But first, a review question. We have been finding the future value of a dollar amount. This is called compounding. So what we've been doing is find F, find the future value, given present, interest rate, and n. What we're going to add on today, new information, is how to find the present value or present worth of a future sum or a set of cash flows. This is the reverse of the compounding process that we've been doing previously. This finding the present worth of a future sum is called the discounting process. So here are the important items here. What we're looking to do today is to find P given F, I, and N. Here's the formula. If you like to solve these using the equation, that is just fine. There it is, to solve for P, present value. Or another way is to say find P given F, and then in parentheses here, this is actually going to be, we have pre-established interest tables that have done this math for us at a variety of interest rates and a variety of time periods. And those factors have been established and are published in the interest tables. And so we can solve an equation like this by using this line right here, find P given F, and then times a factor found on the interest table. In that column, find P given F at that interest rate and for n number of terms. Write these down in your notes, these 3, this is important. All right, so there it is again. And I want to highlight just a couple of things here. We're looking today to find P given F, I, and N. So this formula right here can be summarized to P equals F times 1 plus I raised to the negative n power number of interest compounding periods. When we're finding P, we're given the future value, one cash flow into the future, and we're looking to find its present value. We still use this letter I, but now we're calling this the discount rate. It's still the same letter. It still is a percentage, like an interest rate. But when we're discounting back in time, we call this the discount rate. So basically, you discount a set of future cash flows. We're just going to be working with a single sum right now, back in time to find the equivalent present value. And here again, wherever you see something in parentheses like this, it's that whole thing signifies a discount factor found in the interest tables. Find P given F at a certain interest rate, discount rate for a certain number of time periods. All right, let's do an example. So given a future value of $1,000 with a discount rate of 6% per year and a term of 8 years, find P, find the present value equivalent. Here again is the equation, and method 1 is to solve it on our calculator using that equation. So present value, what we're looking for, equals $1,000 future value times 1 plus 0.06 interest rate or discount rate to the minus 8 power. That's n number of time periods. So 1,000 times, that math works out to 6,274. And so the answer is $627.40 is the equivalent present value, which is equal to $1,000 in the future, given a 6% rate and a term of 8 years. They are equivalent. That's method 1, using the equation, and you can certainly do that. Method 2 has us use the interest tables. So here in this example, I have located the 6% interest table, and term, the n term of years is 8. So I go down to line 8. and then go across. Which column do I go across? Well, we choose the second column because we have a single payment happening in the future, right? One future sum of $1,000, so it's a single sum, and we're looking for its present worth. So find P given F, I, and N. So we go down to where that column and line intersect, and our factor is 0.6274. And so here's how I'm writing that. Find P given F of $1,000 times that factor from the table. Again, works out to $627.40, same as our answer above. I like using the interest tables because it simplifies the math. As long as you choose the correct column and get the number of periods right, you'll come up with a factor and you don't have to do that negative exponent. Method 3 that I'm going to show you is the Excel financial function. You would enter into a cell, this right here, equals PV, parentheses, 6%, comma, 8, comma, for the years, 0, comma, $1,000, comma, 0, and then parentheses. And again, you'll get the same answer. For some reason, Excel returns this as a negative value, but you should interpret it as a positive value. And that, again, is the present value. Here's an example in context. So say you are an investor and you buy a zero coupon bond, okay? What a zero coupon bond means is that you do not receive any interest payments to you during the life of the bond. Instead, you receive face value of the bond at the end of the bond term when it reaches maturity. So basically you would buy the bond at a discount. Now, in our example, you would pay $627.40 now, right? It's present value. And then in 8 years or whenever the bond matures, you would receive the face value of $1,000. It's future value. In any case, no matter you use method 1, 2, or 3 to solve it, the cash flow diagram looks the same. We're given a future value of $1,000 at some time period in the future, and we want to discount it back to find its present value today, given a certain interest rate or discount rate. So in summary, the compounding process, which uses an interest rate to find the future value, and the discounting process, which uses a discount rate to find the present value, they're reciprocals of one another. Here are the two formulas right here. Very similar. Remember the negative exponent when you're looking for the present value. So if you know, or you can estimate the values of any 3 of these variables, then you can always find the value of the 4th. Thank you. The end.